We have a 60 millimeter tube with a 40 millimeter inner diameter. What torque is needed to rotate it 2 degrees if the modulus of rigidity of the material is 77 gigapascals? And we have to assume the beam's 1.5 meters in length. So if we take a look at this, our equation for angle of twist, and that is not the example, our equation for angle of twist is TL over JG. So, at this point we know what the angle of twist is, so I want to rewrite this because I want to find torque. So torque will be the angle of twist, JG over L. Now the problem gives us directly the modulus of rigidity and the length, so we're fine. We're going to have to calculate out angle of twist, and we're going to have to calculate out the polar moment of inertia. Of course, you're probably sitting there going, but wait a second, Dr. Camp, they give us, in the problem, they say it's a 2-degree angle of twist, which is correct. But if you look at the equation, the units aren't going to work out correctly because our torque will have a degree within the units. So we're going to have to convert that over to radians, because the interesting thing about radians is radians kind of get forgotten when you do units. So we're going to have to convert that over. In fact, let's do that right now. So we have angle of twist is 2 degrees. And so we convert that over. Well, how do we do that? Well, there are 2 pi radians in one circle, or one revolution, which is 360 degrees. And so if I multiply that together, my angle of twist of 2 degrees works out to be 34.9 times 10 to the negative 3 radians. Okay, now that we do that, we're going to have to take care of our polar moment of inertia. It's a 60 millimeter tube that's got a 40 millimeter hole in it. So my cross section looks like this. I've got my little donut, which if I look into my equation manual, I'm not going to find a thing for a donut. We have to do superposition, take the polar moment of inertia of the whole thing, subtract from it the polar moment of inertia of the little hole in the middle, and that will give us the ring, using that method of superposition to solve that. So I look up a circle. What is a circle? A circle's pi over 2 r to the 4th. So pi over 2. We'll do the outside radius. We need to convert that to meters, so the units will work out right. So 0.3 meters squared minus 0.02 meters squared. Now, one thing I do want to bring up here, because I see students will do this all the time, is they'll go, oh, well, 0.3 minus 0.2, and then they'll square the difference. You can't do that because the math isn't going to work out right. You need to make sure to square the one radius, subtract from it the square of the other radius. Now, once you do that, you'll get a polar moment of inertia of 1.021 times 10 to the negative 6 meters to the 4th. And at this point, we have everything. We'll just plug it right into our equation. Angle of twist is 34.9 times 10 to the negative 3 radians. Polar moment of inertia, 1.021 times 10 to the negative 6 meters to the 4th. Our modulus of rigidity is 77 times 10 to the 9th Newton meters squared. Why do I do that? To make canceling out these units easier and make sure everything's correct. 1.5 meters is our length. So as I look at things, I've got meters cubed on the bottom. That'll leave me meters on the top. We forget about radians, so I've got Newton meters on the top, which is definitely a torque rating. And so if I multiply this all together, I'll get 1.829 kilonewtons times meter. Oops, sorry, I just forgot what I was writing there for a second. Let's clean this up. So kilonewton times meter. So that's a torque rating. And there we go. And that's how we do that.